કાલે અત્યારે પ્રોબ્લેમ આવું થયો ને એટલે શું કરવાનું કઈ નહીં ફોને પૂછ્યું તો ખરો ના પણ ચાલી કેટલા હું બાપા બાપા એટલે તમે શું કરવાનું વાત નહીં પૂછ્યું અચ્છા તમે બેઠો આપો મને બોલો થોડું હા કરીએ હાલો હા માહિતી ત્યાં વાર લાગે શું કરશો મારા પપ્પા 6 વાગે છૂટશે પતા નહીં આવે બસ તો પાછું વકીલને મળવા કઈ જાય વકીલ ને બોલે છે હા વકીલ નહીં બોલે પૈસા શું થયું સેકન્ડ છે કેટલા ટાઈમ થી છે તમને નહીં ખબર ઘણા ટાઈમ થી એટલે કાનમાં મને પ્રોબ્લેમ પ્લાસ્ટિક મારા કારને ખબર તો છે
स्टार्ट करतो मी कोणाला अटल टाका काय इमेल केला काय पण इनोग्रेशन सक्सेसफुली सेशन झालेलं सेशन चांगलं झालं स्टार्टेड सक्सेसफुली कोणाला टाकायचं सेशन चालू करून झालं सेशन चालू करून झालं सेशन चालू
પીલું જુઓ પીલું ચાલુ કરો એમ્બ્યુલન્સ વાળું એમ્બ્યુલન્સ વાળું આપણે જોતા હતા તે દિવસે
ના આપણું મારે એફડીપી ચાલુ કરે
જરૂર
ના
એ
ભરતી
ચાલુ કરે તો અમુક એમ્બ્યુલન્સ વાળું ચાલુ કરી દઈએ
એક ટોપિક સારો છે એમાં
હા
શીખવા
તો બેસો એક જ મિનિટમાં આવે બેસો
તમારે જીઓ ફાઇનાન્સ કરવું છે
એટલે
Am I audible, sir?
Yes, sir, audible.
Okay, shall we start, sir? Good afternoon, everyone. A very
Good
warm
afternoon, sir.
all participants, respected resource person, to the second session of our expert lecture on conceptual understanding of machine learning. It's a truly pleasure to continue our learning journey today with an esteemed academician, researcher, and innovator, Dr. Neelesh Kumar Sahu. Dr. Neelesh Kumar Sahu is a currently professor and head coordinator robotics and artificial intelligence at Gyan Institute of Technology and Science, Jabalpur. He holds PhD in mechanical engineering from PNIT Nagpur with specialization in machining of difficult to cut alloys and has 10 years of academic and 3 years of industrial experience. Dr. Saul's research interests span a wide range of cutting-edge domains, including uh, including condition monitoring, robotics, artificial intelligence, machine learning, deep learning, optimization, and Industry 4.0. He has guided several PhD scholars, and his work has been published in leading size, Scopus, and Springer Index journals. His research has earned 490 citations with an Yale Index of 21. Beyond research, Dr. Saw has also worked on industry projects and patents, including innovation in gear condition monitoring system, nanofluid applications in machining, and AI-driven prediction models. He has also received international exposure through training and collaborative projects in China and South Korea, enriching his global perspective in manufacturing and intelligence systems. Before we begin, a gentle reminder to our participants, please keep your microphones muted during this session. You may post your questions in the chat box, which will be taken up during the question and answer discussion at the end. Kindly ensure your attendance and feedback are submitted as per instructions after this session. Once again, I welcome you all to this engaging and insightful session of machine learning. Now, without further delay, I request Dr. Neelesh Kumar Sahu sir to kindly take over and begin his presentation. Sir, the virtual platform is all yours. Sahu sir, please continue.
Yeah, yeah, yeah. Am I audible?
Yes, sir.
Yes, sir, I'm audible, sir.
Yes, sir, audible.
Okay, okay. So thank you, sir, for your nice introduction. And I apologize because of there is some setting error in my laptop. I am not able to own my camera. However, I am able to share my PPT. So is it visible now?
Yes, visible,
Yes,
sir.
sir, visible, sir.
Okay, okay. So thank you for inviting me onto this Atal FDP program. And also want to thank Dr. Muhammad Ali for inviting me for this particular program. So today's topic is a conceptual understanding of machine learning. I don't know about the audience whether they are from which background. So I am from the mechanical engineering department, and most of our colleagues in few years back they are not aware of this machine learning concept. But nowadays everybody knows about this machine learning concept. And before this session, I think one session was on Industry 4.0. So all of you have gone through what is Industry 4.0, which is fourth industrial revolution, and in which a lot of new technologies are incorporated into the industries for make it smart. So smart manufacturing is a recent trend since 2014, and there are so many technology which are coming together and improving the performance efficiency of the industries like artificial intelligence, machine learning, deep learning, and advanced robotics and 3D printing, so on, reverse engineering and augmented reality, virtual reality, digital twin. All these new words are coming from last 10 to 15 years in the presence of Industry 4.0. and we are also moving towards industry 5.0, which is more human centric. But the today's topic is restricted from my side is only onto the machine learning. So we will simply basic understand what is machine learning. We will discuss some real examples, real case examples on the machine learning. So let us begin with this. So this will be the outline of my topic presentation today. First, I will define what is the machine learning, then what are the types of machine learning, and where the machine learning are applied in mechanical industries and other industries. Then there are some keywords which are used generally in the machine learning, like hypothesis, the base, and one in basic algorithms I will discuss. There are so many algorithms in the machine learning, but I will discuss today on the regression, types of regression, and evaluation of the model, whatever model we are developing for the machine learning. So all of us understand and hearing these words AI, ML, DL. All these words are very common nowadays. So AI basically means so AI is the bigger picture and big umbrella. Inside AI, there are two methods like machine learning and deep learning, which are inside the AI. So what do you mean by AI? So AI means make a machine which will behave like a human. It takes decision like human being on a real time situation. So that is called artificial intelligence. And nowadays there are so many things which we are looking in our daily life. There are so many performance evaluation, and based on the performance evaluation, the machine learns to perform the task. So we will further in the next slide we will see the proper definition. And the basic definition in the machine learning and deep learning, both are same. They are developing nothing but the model which is able to take its own decision. But the main difference is on the data. The machine learning generally work on the simple data like text data, all these things it is working, and deep learning is basically perform on new form of data like video, images, and where the amount of data is very large. So in these scenario we utilize the deep learning, but the core definition of the machine learning and deep learning is same, so that we can develop a model by training and by performing some task, and based on that performing of the task we measure some evaluation parameter, and based on the evaluation parameter we decide the model is performing well or not. So AI is the bigger picture and machine learning and deep learning are inside of this. Now by this slide I think you will understand what is the machine learning. So basically when we do the programming, in the programming what we do, we create a logical statements, and in the logical statement after developing a program, if we supply some input it will give you accordingly some output. So that is called a basic computer program. But in case of machine learning, we supply both input as well as output of the previous history data. So we at the same time we both supply input as well as possible output or actual output which were measured during the experiments. So when we supply this both input and output to the machine learning algorithm, it will get trained, and based on the training and after proper evaluation, it will build some logical model. And after the model is built and we measure all the performance evaluation parameters, then in the next step we supply the new data which is not used for the training purpose. So when we supply the new input data, it will automatically give you some output. So that is the basic function of machine learning. So in the machine learning, what happens? If we develop a model, such that it will automatically give you the output without yeah.
என்னடா தம்பி நீ ஹாஸ்டல் ஸ்டாஃப் சாக்லேட் உங்களுக்கு என்ன வேலை?
Your PPT is not visible to us.
என்ன வேலை?
Okay, your PPT is not
வந்து
visible.
ஹாஸ்டல் இது டேஸ்ட்
Yes,
கிடையாது.
please share it.
வெளியே வா.
Now visible, sir.
Okay.
Please make full
Previous slide was visible.
ஆ?
No, sir.
புரியல.
Previous slide also now.
உள்ள போங்கடா ஏகே ராஸ்கல்களா.
Okay.
போங்கடா ஏகே ராஸ்கல்களா.
அவர் வந்து 2 டிபார்ட்மெண்ட் போறதுனால பார்க்க முடியாது. என்ன சரி
அது இன்னும் மாறண்டது இன்னும் மாறும். என்ன பாருங்க. ஆமா
நீங்க வரலீனா சார் மாறும்
மாறும். நம்மளுக்கு வந்து
அப்படிதான் சொன்னாரு. இது
Now is it visible?
கேட்டேன் நானு.
Yes, sir. Visible.
சார்
Sir.
எங்களுக்கு சிலபஸ் வந்து மாறுது. அவரே இருக்கு சார் அப்படின்னு ஏன்னு கேட்டாரு.
கண்டிப்பா
சார் ஸ்டார்டிங்ல அவரே எடுத்துட்டு வேற ஸ்டாஃப் பண்ண கன்ஃபியூஸ் ஆவாங்க.
Okay, this slide we have not. Please unmute. Please mute other.
அதனால நீ கவலைப்படுது சார். இதுவே கிடையாது, பர்மனண்டே கிடையாது.
I'm getting a lot of noise.
பசங்களாம் எப்படின்னா
Okay. So this is the slide I was discussing. So AI is the bigger picture. AI means
மெக்கானிக்கல் வர வேண்டாம்.
Develop a machine which will behave like a human being, and during this development, machine learning and deep learning are just the two methods, okay, which are you help to train machine like which behave like a human being. So this was the slide I have already discussed. Now is it visible, this next slide?
Yes, sir. Yes, sir. Visible.
Okay, so basically what is machine learning? It is somewhere different from the computer program. In the computer program, we make some statement, logical statement, and inside the logical statement, if we supply any input, it will give you output. But in case of machine learning algorithm, we supply the data which is having input as well as output. So input and output data both are, you can have your previous history data, or you can generate some experiment data. You can generate the data from conducting some experiments, so that data is available to you, and from that data you supply onto the machine learning algorithm, and machine learning what it does, it learn from that data and it will create a model. So output of the machine learning algorithm is nothing but the model. If we compare with the computer program, it will give you output, but in the machine learning algorithm you will get some model, and what that model will do, that model will take a new data which is not used in the training, and automatically it will give you the output. The output can be of any form. Okay, so basically if we develop a model, machine learning model, it will give you possible decisions, or possible classification, or possible future predicted values. So this is the main aim of the machine learning. So in the machine learning, what we do, we develop a model. That model will predict, will classify, or will associate some value, or will give you some decision out of input if we supply any input to the model. So the output of the machine learning is the model which we developed, And how the model is developed, it developed by some previous data, from history data or experimental data. Now, basically, one should understand when we learn about the machine learning, you should have some computing knowledge, some mathematics, and some statistics knowledge you should have before you go into the machine learning or you learn the machine learning. So this background is aware of the statistics, which we will see in the evaluation part, mathematics, equations, quadratic equations, coefficients, that you should understand, computing, how to do the optimization. All these things you should understand before you go into the machine learning. Next, now, if we talk about the basically, so in my today's talk, I am only focusing on the machine learning. We are not focusing on the deep learning model. So I will be giving you the inside of the machine learning, and I will give you one model example of the machine learning. So basically, elements of machine learning, if we talk about, there are basically three elements of the machine learning. First is the representation. So representation means what kind of problem you are having. In real life, there are so many kind of problem. In case of machine learning, like one is called regression. Regression means you want to predict the continuous value, continuous numeric value. For example, what will be the temperature in the night? What will be the temperature in the day? Okay, what will be the amount of people which will come tomorrow? Like that. These are the continuous numerical value. That is called regression. Then another one is the classification. Classification can be binary, ternary, or any kind. So binary means yes or no, true, false. Ternary means yes, no, maybe. So these are the classification kind of problem which help in decision making. Okay, and some problem are related with the clustering. Clustering means creating a group of data. So all these come under representation. So representation means regression, whether the problem is related to regression or problem is related to classification or the problem is related to clustering or the problem is related to association of the data. So all these are the representation part. The next part is optimization. So in the optimization, what you do, you develop the model. You develop the machine learning model by building the relationship between the input and output through calculating the coefficient. I will give you one example on this so you can understand easily. So in the optimization, what we do, we find out the best value of coefficients for developing the model. So basically, model is nothing but the mathematical relation between the input and output in case of machine learning. So how we develop the relationship? The relationship can be developed using calculation of the coefficient. Then third part is the evaluation. So whatever model you have developed, you cannot directly utilize it into the real world situation or a real problem or real life example. So before you apply, you have to must first evaluate whatever your model is performing. So there are some parameters by which you can say that, okay, my model is performing good or model is performing bad, or it should require more training. So the evaluation part is also very important. So there are some parameters like mean square error, root mean square error, R square values, confusion matrix in case of classification problem. Okay, and there are so many other parameters in case of clustering problems. So these are the three elements. First is representation, next is optimization, and third is the evaluation of model. Now come to the types of machine learning. I will quickly go through this. Basically, machine learning are divided into mainly three parts. First is the supervised learning. So in the supervised learning, whatever data you're having, it is having some label. Like for example, you are having some Excel with you. In the Excel, you are having a data, and each data is arranged in the column, and you are having some heading to the column. For example, you are having some data related to your classes. If you are in a academic part, so in the name, roll number, marks, subject name, all these are the headings of the data. So like in this example here, we are having the data in the form of images of the fruit. Okay, so here the input data is labeled like which is banana, which is apple. So this labeled, whenever we are having the data, training data in the form of labeled data. Labeled means whatever input and output you are having, it is having some associated heading with it. So like here in the example, apple are annotated by apple and banana are annotated by banana. So now when we supply this training data to the model, it will behave like a supervised machine learning, supervised learning. Okay, so in the supervised learning, the data which is available to us is in the form of labeled data. So you are having the complete knowledge of the data, which column is representing what. So that is called the supervised learning. Okay. So here in this example, what is happening? We are supplying some training data in the terms of banana. It will develop some model, and when we supply that it is a apple, it should not predict it is a banana. When you supply the apple, it will automatically predict you, give you the answer as apple. Okay. Now next is the unsupervised machine learning. So basically in unsupervised, here in the supervised machine learning, there are basically two types of problem we deal with. One is the regression problem and another one is the classification problem. Classification, whatever data you are having, you are segregating it into the two parts or three parts. Like here, and this is the kale and banana. Out of these two images, you have to classify the image whether it is the apple or banana. So this is the basic general example of supervised learning. But if we talk data does not having any labels. So you are having some data, and that raw data you are having, you might have created some what we call as Google form you have circulated to the people, and people have filled the Google form, and everybody filled with some different characters or different numbers. Okay, so you are collecting some data after the survey, and that data is in the raw form. You are not providing any label to it. So when no labels. So in that situation, it is called as unsupervised machine learning. So here is the example. Here we are having the images of cats and dogs, but we don't have assigned any label to it, which is cat, which is dog, we don't know. So KNN method, and one is I forgot the name, evaluation algorithm method. So there are so many clustering methods which are used to create the group of data. So how we create the group of data? Based on the dimensions, based on the shape, or based on the size of the data, we can group together. Like for example, here you can see, okay, these two animals look the similar. Two images look like cat and two images look like dog. So we can create a group. In the same manner, in the mechanical industry, you are having some circular shaped rod, or you can have a square shaped plate. So based on the shape, you can you can create the group of the data. It is like a group technology in mechanical engineering, in advanced manufacturing industry, group technology, how we group the material and machines. In the same manner, we create the clustering in the data in case of unsupervised machine learning. Okay, so basically in the unsupervised machine learning, the output is in the form of cluster. In case of supervised machine learning, we are having either regression or classification, but in case of unsupervised machine learning, we are having the output at the form of cluster. So you can see here in this image, the output is at the form of all the dogs are grouped together and all the cats are grouped together. Okay, so this is unsupervised machine learning. And third one is the reinforcement learning. So in the reinforcement learning, am I audible? My slide is visible to everyone? Hello? Hello, everyone. I am visible, audible? Okay. So, and the third type of machine learning, which is called reinforcement learning in the ML. So here, what happens? I will give you an example. Here we talk about some agent, and that agent is going into some environment, and from the environment it will learn. For example, what happens when you, as a kid, when you are very small, 4 to 5 years old kid, how to ride a bicycle? There is no such rule. By simply sitting on the bicycle and making the pedals and balancing your bicycle by your own, you learn how to ride a bicycle. So you, in that situation, you were the agent. You were exposed to an environment to ride the bike, and there is no bicycle, and there is no such physics or mathematics or chemistry which should be followed. So everyone understand by your own action. Everyone learn how to ride a bicycle or how to ride a bike by his or her own experience or own actions. So based on that, this reinforcement learning is nothing but that is there is some agent. Another example I want to give you is that in case for this kind of problem is I think everybody has watched PK movie of Amir Khan. So in the what happened in the PK movie, Amir Khan was came from different globe, from different world to the earth, and in the earth he saw one guy that he is giving you he is giving some carrot to a person by showing the image of the Mahatma Gandhi. Okay, so he thought that if I will also show the image of Mahatma Gandhi, I will also get the carrot. But he showed one big picture to the of Mahatma Gandhi, but he did not gave him the carrot. Then he showed the image of Mahatma Gandhi on a currency note. Then that person gave his the carrot. So he, by performing some task in the environment, he understand, okay, picture of Mahatma Gandhi is not important. Image of Mahatma Gandhi in the currency is important. So by this, he performs some action, he gets some reward. So he perform, if he perform good task, then he will get reward, and if he perform good task, he will get some penalty. So in that situation, by its own experience, it will learn. So in reinforcement learning, what happens? There is an agent which will be sent into the environment, and on the environment, based on its action, it will get some reward or penalty. If it is getting reward, he will follow the same action again and again. If it is getting some penalty, it will not perform that same task again and again. So any industry problem, we can say the automated guided vehicle and robots are the biggest example of reinforcement learning, especially when it is used for the material handling, and it will follow some line from certain path. It should follow certain path to reach to the material, and during its follow and during following the path, it should not get structured with some physical object. So it should avoid the obstacle, and also it should follow the optimum path. So in the reinforcement learning, and the biggest example is the robots used for the material handling in industries, for material handling and other inventory purposes. So this is the third category of machine learning. So we have seen supervised machine learning, unsupervised machine learning, and reinforcement machine learning. So these are the three basic type of, and inside all these three categories, there are so many algorithms. Like for example, in the supervised learning, we are having regression, then decision tree, then KNN, and there are so many other algorithms. In case of clustering, we are having K-means clustering and hierarchy method, hierarchical approach, and there are other so many. In case of reinforcement learning, also there are so many algorithms which are used for the learning of agent. So these are the basic three types of machine learning. So again, this is the summarization of all the three method, all the three types of machine learning. So supervised learning, we are having some algorithm. In unsupervised machine learning, we are having some algorithms. And in reinforcement learning, we are having some algorithms. In all the three category, whatever model we are developing, we have to evaluate all these models, the performance of each and every model. Without evaluation, you cannot directly utilize it into the real world situation. So whatever you are developing the model, first you have to evaluate, then you have to go for application of the model. Okay. Okay. Okay, now for your understanding, one basic example of supervised machine learning I'm discussing here. This image I am taking from one NPTEL video, very simple to understand. So this is the data. This is the supervised machine learning data. We are having labels to the data. The two values are coming as age versus income. This graph is showing age versus income, and these dots are nothing but the blue color dot are nothing but this is the data from some shop where we can say, okay, a person will buy a computer or will not buy a computer. So this is the data from a computer shop where we will decide whether the person or customer buy computer and or not buy a computer. So in case of supervised machine learning, whatever we are having, it should have the label. So here we are labeling the data. So this is how the data is labeled, and you can see the red color dot is saying that person will not buy a computer, and blue color dot will represent that person will buy a computer. Okay, so this is the data we are having from the previous survey or previous year sale, and this data is associated with the two input feature. One is age and another one is income. So you have to decide based on its age or income whether the customer will buy the computer or not buy the computer. So before customer says something, you can predict, okay, he or she will buy a computer or not. So this is a very simple example. Now what we will do, we will fit the model inside this data. Okay, so that model, and basically this is the problem of classification. It's not the problem of regression, because here we are classifying in two categories, yes or no, whether the whether the customer will buy the computer or not buy the computer. So this data will be classified based on some model, using some model. So there are so many type of model you can fit. Okay, so it is not a thumb rule. Okay, you directly having one simple model, you have to try and error with some different categories. So here, whatever I have drawn, I have made a simple straight line. So this black color straight line is nothing but by my model. So this model is classifying the data between buy a computer and not buy a computer. But in this model, what I have considered, I am considering on if you see, I'm considering only the income. I'm not considering the age. So what this model suggests is that a person with certain age will buy the computer. If it reach age computer, and less than 40-year person will not buy the computer, because this horizontal axis is representing the age. Sorry, income. So this horizontal axis is representing the income. So this model is representing the classification of the customer based on income. So if certain amount of income is, if it is more than certain amount of income, he or she will buy the computer, or if it is less than the amount of income, it will not buy the computer. And here we have not considered age for classifying the data. But still you can see on the right side of the model, or the right side of this line, there are some blue dot also. So it is not only classifying, only classifying the data. There are some error in the data. So these 3% will, even if they are having some amount of income, but they are not buying the computer. So you cannot directly say based on income that person will buy a computer or not. So I further modify this model. So in the left side image, you can see I have used a different model, which is inclined. Now in this situation, what is happening? I am considering income as well as age. So now in this left side image, you can conclude that at higher age, at certain amount of income, people will buy a computer. And at lower age, even in less income people, again it is classifying properly, but you can still see that one blue dot is coming on the left side and one red dot is coming on the right side. So still there are some error. Okay, So by the way, you cannot remove 100% of error. There will be some certain amount of error. So in this left side image, what I have considered now, age as well as income. So this straight line, which I have inclined with some y-axis. So it is also considering the age. So with certain amount of age and with certain amount of income, people will buy the computer, and certain amount of age and certain amount of income, people will not buy the computer. So here I am classifying it. Now, further, I can improve now. So far, we have used only straight line. Now, in straight line equation, we already know. Everybody know the equation of a straight line, which is y is equal to mx plus c. Okay, so it is very simple, and that y is equal to mx plus c is nothing but the linear regression. In other words, somehow we increase the order of that equation, so it will leave straight line and it will create some curvature. So this right side image, I am further added some feature into the model, and I have made it from straight line, I have made it curvature like equation. So some quadratic equation is developed like y is equal to mx plus ax plus bx square plus c, like that model I have developed. Still, you can see it is performing better than previous one, but there are some red dot, only one or two red dot on the right hand side. So again, this is the error, but this error you can say as a noise. It is like, for example, if somebody was coming to buy, it should buy a computer, but at the same time he got a urgent call and he left the shop, so he did not buy. So there are some noise in the data. So these are the noise you should avoid. So still we can say that the third model in the curvature is performing better. So this what I'm showing you is the example of supervised machine learning for classification. So from the same data, I used three types of model. One is the vertical straight line, another one is the inclined straight line, and third one is the curvature. So you can say the third model, which is having the curvature, is giving you the best output. Okay. Further, I can also increase to avoid this situation. You can say, okay, this is having 0% error and 100% performance. But the more you try to fit the model, you can see the complexity of the model is very high. You can see you cannot define the equation of this particular model. It is very complicated. And if you use such kind of equation or such kind of developed model in real world application, what will happen? During the training phase, it is performing well, but when the real time, when you validate on the testing phase, it will not perform good. So this type of situation we should avoid. This type of model we should avoid. This type of complicated model we should avoid. And this is, in other words, we also called as overfitting of the model. So overfitting we should avoid. Overfitting means adding more and more feature into the model in order to get it reduce the error. Okay. So it will perform well in the training phase, but it will not perform well in the testing phase. So that is called overfitting, and one should avoid this overfitting of the model during the training phase. Okay. So out of all these four model, I can say that this third model, which is having a curvature, is the best one. Okay. So this is the
Sahu sir, are you there? Hello?
Hello, am I audible?
Yes, sir. Yes, sir, you are audible.
Uh, when I left the meeting, which slide? This is covered in the previous.
Let me see.
Okay, so I was in this particular slide. Now is it visible to everyone?
Yes, sir. Yes, sir, you are visible.
Okay, okay. Yeah, yeah. Thank you, thank you. So I was talking about this developing a prediction model for regression problem. So here the regression means predicting the continuous numerical value. The previous example which I gave you is for the classification. This is for the regression. So in the regression, what we are trying to predict is the temperature based on the time, day or night.
Sir, please
So
make it full
here
screen.
in the previous data,
Sahu sir, please make it full screen.
okay, okay. Wait.
Okay, sir.
Now is it full screen?
Yes, sir.
Ah, okay. In this situation, what I am doing, I am trying to fit each and every data point. So in this situation, what you will get? You will get the 0% error and 100% output. But this is on the training phase. But when you deploy this particular model, this complicated zigzag blue line into the real problem, what will it do? It will not give you the perfect answer. It will not give you the proper result. So this type of situation is called the overfitting. When your model perform very well in the training phase and does not perform in the testing phase, it is called overfitting. So you should avoid all this overfitting. Compared to previous slide, this is better. This model is better. It is having some error, but it is error is in the acceptable limit. So this uncomplicated model is good compared to this complicated model. So the two types of example we have seen in case of supervised machine learning. First one is regression problem. First one is the classification problem, that the person will buy a computer or not buy a computer. And second one is the temperature, predicting the temperature based on the time of the day, whether it is day or night. Okay. So this is how we calculate the error. So you can see this model is having blue straight line is our model which we have developed. Okay, and the red cross is the actual data. So how much your data is deviated from the model value. So this difference we have to predict, and how we will calculate? We will calculate as a sum of square error. So you can say that sum of square error is the predicted value minus actual value to the square. Now here why we are doing the square, it is very important. Why we are doing the sum of square? Because the difference may be sometime negative, or difference may be sometime positive. So in order to compensate the negative and positivity, what we are doing, we are calculating the sum of square error. So sum of square is nothing but the predicted minus actual value to the power 2. Okay, so we have to minimize that particular equation. Again, in a ahead slide we will see. So I'm not showing here is the example of clustering. I have shown you already the problem of supervised machine learning, that is regression and classification. Unsupervised machine learning example I am not showing in this particular lecture, but the problem of clustering is the example of unsupervised machine learning, where you will create a group of data, the data which are available to you. You create a group out of these data. Okay. So this is the possible application of the machine learning algorithm. So far, our mechanical engineering people are also utilizing it on a very rigorous manner. And even I have also utilized these algorithms into my experimental work. And so in the case of manufacturing, in the field of manufacturing, in the field of healthcare, everywhere, insurance, customer service, transportation, e-commerce, automobile, everywhere it is utilizing these models. So e-commerce, one example I would like to say that whatever now you're seeing on the Facebook, if you go to the Facebook nowadays, automatically suggestions for the video comes to your wall. Okay. So how it comes, where whatever you are seeing previously, based on that it gives you some suggestions. Okay, you will like this video, this type of video you can like. In the same manner, if you go to the Flipkart or Amazon, whatever whatever product you have searched before, it will give you for the suggestion in the future. Okay, you would like, if you want to buy a mobile, or if you want to buy a laptop, or if you want to buy any other product, if you search for any product, so based on that your search history, they will automatically give you some suggestions for the new product. Okay, so this is usually we are feeling nowadays. So everywhere in the field, it is machine learning is utilized. So in the back end of these suggestions is nothing but the machine learning. So this is one industrial example, simple industrial example. Here, what I want to classify whether it is a nut or bolt. Okay, so what you will do, you will supply some images of bolt and images of nut to the model. Okay, and based on the image, it will learn. These images are having some label. So whatever image is having bolt, it is labeled with the bolt. Whatever the image is having nut, it is labeled with the nut. Okay, so these images are supplied for the model to learn, and after providing sufficient data for the training purpose, the model will develop, and we, after evaluation, we will reduce the error. Okay, and after reducing the error, we will develop such a model for the future. So in the next phase, what I will do, I will do the testing. So what in the next phase of testing, what I will do, I will supply another image. Like you can see here at the bottom, I am supplying the image of bolt as an input data, and this model, whatever the model which is developed here, it will automatically give you answer whether it is the nut or bolt. Okay, so if it is a bolt, then it is correct. If it is a nut, it is not correct. Okay, so this is one example. In the same manner, there are so many examples. In the quality check also, we can utilize the machine learning algorithms based on the quality, shape and dimensions. You can segregate the product in the quality control department. So if certain so quality control you can easily do with the help of machine learning, with the help of these machine learning models. And there are so many machine learning model already developed based on the image data, and you can directly utilize these model into your project or into your work. Okay, so there is one platform which is called TensorFlow hub. In the TensorFlow hub, you can find so many models trained on the images data that you can utilize. Okay. In the health sector also, if I say during the COVID period, based on the image data, we can predict whether that person is how much infection on the its chest or any other disease like MRI, CT scan data that is utilized for predicting the level of the we can say level of the illness on the person. But utilization is more, but there are some drawback of also the machine learning algorithms. One of the drawback is the lack of transparency and interpretability. Means whenever you supply the data to the model, it will learn from that particular data, but there is no influence or there is no interpretability. Means what will happen if we increase the certain value in the data, if we decrease the certain value in the data, that it is not able to predict, give the answer as machine learning model. And another problem is bias and discrimination. So as we have seen, there are so many these models which I have shown you previously on the previous slide. One straight line, one vertical line, one curvature line, one complicated model fitting all the data. All these are nothing but the bias. So if we somehow select incorrect model, so it will not give you the proper result. Another problem is overfitting and underfitting. Overfitting, I have already told you. So overfitting means the model is performing well in the training part, but it is not performing well in the testing part. But in case of underfitting, what is happening? Underfitting in the field, in case of underfitting, what is happening? Model itself does not perform in the training phase also only. So testing, we do not go for testing. If the model does not perform on the training, it is called underfitting. The fourth one is very important, limited data availability. This is the real problem for the mechanical engineering and other core engineering person. If we want to develop the model in his field for some predicting some output, for example, you want to predict the surface roughness of the machined part, but how many experiments you can perform? 220, 30, 50, or maximum you can perform 100. So this 100 experimental data, training from this 100 experimental data, you cannot develop the proper model. So this is the very difficult situation for the, but today, nowadays, what is happening, there are new models which are coming like generative AI. So generative AI is developed nowadays. So generative AI means itself is saying generative. So what it does, it generate new data. So if you are having a small amount of data, from that small amount of data, it can generate synthetic new data, which can be used, utilized for the training purpose. I have developed one model using this for the prediction of my result, and I got some successful result. So this can be overcome. Another method for generating the new data is the data augmentation. By the data augmentation also you can generate the new data. So computational resources, another difficulty in case of machine learning, because if you are developing a large model which is having large number of input features, so you should have a high amount of computational resources, like we can say that the CPU should have high configuration. Lack of causality, again, it will give you the answer, but it will not give you the reason for why it is giving its answer. Ethical consideration is another. It does not. Any model will give you the output, but it will not look onto the human thinking like a human. It cannot think like a human. Okay. So these are some limitation of the machine learning algorithms. So these slides are visible to everyone.
Yes, sir.
Hello. Yeah.
Yes, sir. Slide is visible.
Okay. Thank you. Thank you. This is another example of machine learning in the field of predictive maintenance. Often we occur with the fault in the machines so many times. In industry, we are working machines are running day and night in the continuous three shifts. So there are possibility that some fault may occur. Now there are so many moving parts inside the machine. So we are having some scheduled maintenance of the machine, but the problem may occur anytime. So you should continuously monitor the behavior of the machine, whether it is working fine or not. So how you can do? You can take the continuous data from the various sensors. For example, you can measure the temperature from thermocouple. You can measure the vibration from accelerometer. Okay, you can measure the force using dynamometer, which are incorporated into the machine. And if the value of these vibration, temperature, force reaching some insignificant value, immediately you should stop the machine. So there, how you can do this? You can do it by application of the machine learning, which will be able to take the decision whether we should stop the machine or not. Okay. So in the field of maintenance also, you can utilize the machine learning model as a mechanical field. Okay. In this situation, what is you are having? You are generating the data using some sensors which are measuring the physical parameter like pressure, temperature, force, any other like strength, whatever you can say. Okay. So by this you can avoid the catastrophic failure of the equipment or machine, and complete shutdown of the plant you can avoid. And if the plant is completely shut down, it will cost lots of crores of rupees for an industry if we talk about. So this graph is also again what it is showing, where we should perform the maintenance when it's reaching some alarming value. You can see here, if the value is reaching some high threshold value, more than threshold value, so immediately it should give you some alarm. And how it will give you alarm? By the application of this machine learning models. Okay. In the design also you can utilize this machine learning, means based how much should be the dimension, how much should be the length, diameter, thickness, width, volume, and what should be the material for a particular product. Based on the previous history, you can directly we can get the suggestion, okay, which material is good for which component and what should be the dimensions. So automatically in the machine learning model will give you the solution. So everywhere you can apply. I think this industry 4.0 in the beginning I have introduced to you, and in the morning session also you have introduced with the industry 4.0. So I am not going to cover this slide rigorously. So industry 4.0 already we know, fourth revolution of industries, where we are utilizing so many technology together. Okay, so now there are some keywords which are utilized. We will discuss one by one. So far what we have covered, we have understood what is machine learning, what is the type of machine learning, okay, and what is the application of machine learning, what are the limitation of the machine learning, what difficulty we are having in the machine learning. But during the training period, there are some keywords which are used, like hypothesis. Hypothesis is a very common word. It is used for your research every time, whether you are doing your MTech or PhD or any other thing, any other research you are doing. The hypothesis is nothing but the initial assumptions. We assume something, whether if we do this, if we perform this task, it will give you this result. This is the assumptions we made. So ML people, machine learning professional also make some initial assumptions about the data. And so there is not, unlike this, our research, in the machine learning, there is not a single assumptions. In respect of single, there are so many assumptions, or we can say there are so many models which we apply on a particular data. Out of these models, which model will perform well, that we have to evaluate. So the hypothesis is defined as the supposition or proposed explanation based on insufficient evidence or assumptions. So on this particular data, this data is of classification plus and minus. So which model will perform well on this particular data? So we have used 3 or 4. straight lines. These blue lines are straight lines, and these blue straight line are nothing but the models which we are applying onto the particular data, and we are assuming that these model will easily classify this particular data in plus and minus. So all these three models are nothing but the possible hypothesis, and also in other words we can say this as a hypothesis space. So utilizing 3, 4, 5 model on a particular data is nothing but called the hypothesis space. So hypothesis space is the composition of all legal best possible way to divide the data or classify the data. Okay, out of these 3 or 4, which is performing well, that you have to evaluate. And statistics also we applied on the machine learning. So I think these two terms are very common to the person who are doing some research, who performing some experiments, that is null hypothesis and alternate hypothesis. So whenever you want to build the relationship between input and output, what you initially assume that there is no parameter which are significantly affecting the output. That is called null hypothesis, and that null hypothesis we have to reject. We have to always go for the alternate hypothesis. What alternate hypothesis is saying, at least one of the input feature is affecting the output. For example, I will give you the example of simple surface roughness and cutting parameter. If you perform the turning operation, there are 3 cutting parameters you can vary: cutting speed, feed, and depth of cut. So in the null hypothesis, you are saying that neither cutting speed, feed, or depth of cut, nothing is affecting the surface roughness. But alternate hypothesis means either at least cutting speed or depth of cut or feed rate, at least one of them is affecting the surface roughness. So this is called alternate hypothesis. But so we are, as a researcher, we always avoid null hypothesis and go for the alternate hypothesis. So what happened? How to verify this hypothesis? So we perform some tests. I think statistic person understand this: ANOVA, app test, t test, z test, chi-square test, u test, h test, and these are called parametric test, non-parametric test. There are so many statistical software which are used nowadays: SPSS, Minitab, and design experts. There are so many parameters. Even Excel, Microsoft Excel also give you these kind of tests on the data. So based on this statistical analysis, you can say, okay, which hypothesis is correct, null hypothesis or alternate hypothesis. So these are some values. Significant level means initially we assume that our experiments are 95%, having 95% confidence level. So more than 95%, we will consider, okay, this is a significant value. So it is useful to define the tolerance of error and the level at which the effect can be considered significantly. Similarly, another term is called p-value. So p-value, if it is the value of p is less than 0.05, so we can say that, okay, that particular input feature is having significant effect on the output. So this significant p-value and significance level for each and every input feature we have to calculate. And like, for example, cutting speed, we have to calculate the p-value for cutting speed. We have to calculate the p-value for feed rate. We have to calculate the p-value for depth of cut also. And the value of p, if it is less than 0.05, we can say, okay, this particular input feature is having effect on output. Now we will discuss one simple model in case of machine learning on the supervised machine learning. So regression is the basic fundamental machine learning model. And based on the regression, there are so many models are developed. Even ANN, if you talk about the artificial neural network, in the artificial neural network, we are having some black box. Inside the black box, there is nothing but this. There are so many linear regression equation, y is equal to mx plus c. Okay. So regression analysis is a statistical method to model the relationship between the output and input. So here is the one example, very simple example. We are having some data. Oh, sorry. You are having some data, advertisement and sale. So here I predict that, okay, if we spend $90 on the advertisement, we are getting the sale of 1,000 rupees. If we are spending on $120 on the advertisement, we are getting the sale of $1,300. So on. So from this data, we can say that, okay, we are spending more on the advertisement, what will be the sale is increasing. Okay, but from the regression, what we can predict, we can also predict a particular amount of sale. So based on these 5 data points, from 1, 2, 3, 4, 5 data points we are having. So using these 5 data points, we can build a relationship between advertisement and sales. So sale is our output in this situation, and advertisement is the input. So we have to build the relationship between the sales and the amount of expenditure done on the advertisement. So in the future, what we want to do, if we spend $200 on the advertisement, what will be the sales that we want to predict? So how you will predict? You will develop some model between the advertisement and I think these are some terminology related to regression. So here in this particular data, sale can be represented as Y. Y is sales, and another word we can call it as target. So dependent variable or target or Y we can say. So in the previous example, the sale is the dependent variable or target or Y. Dependent means its value depend on the input. Okay. So sale, if we want to increase the sale, we have to spend more on the advertisement. So here some example of dependent variable like temperature, age, salary, price, sales. Independent variable are nothing but the input feature. Here in the previous example, the expenditure on the advertisement is the independent variables. So we can independently spend on advertisement. Okay, we can spend $100, we can spend $200, we can spend $300 on the advertisement. It's up to you. But how much you are spending on the advertisement, the sales will get some effect. Okay, if you are spending more sales you will get. So heat, experience, cost, advertisement, etc. are the independent variable. Outlier are nothing but the noise in the data. There are some unusual observation during the collection of the data, which is called outlier. Okay, multicollinearity means multicollinearity I will tell you later in the another example. Underfitting, overfitting, I think already I have told you. I'm not going to repeat. So these are some advantage of regression analysis. What are the advantages? You can estimate the relationship between input and output. You can find a trend in the data. As in the previous example, I was saying that as you increase the amount of amount in the advertisement, your sales value is also increasing. So that is the trend, and the real and continuous value you can predict. Okay, and you can also find out the effect of input to the output. For example, from the previous example, you can easily say that as we increase the amount in advertisement, we will get the increase in sale. If we decrease the amount in advertisement, we will get decrease in sale. So this kind of effect you can find out. And regression is also, there are 4 types of regression: linear, multiple, logistic regression, polynomial regression. Out of these 4 regressions, logistic regression is used for classification. Linear regression, multiple linear regression, and polynomial regressions are used for continuous prediction, continuous numeric value prediction. Okay, so this is very example of linear regression, where you are having output as salary and input as experience. So you want to build a model that what is the relationship between the experience and the salary. So we are developing this black line is nothing but the model we have developed on the green dot data. Okay, so you will develop a model which will give you, okay, if I am having 6 years of experience, what will be my salary? Okay, so this is called a linear regression. And if we talk about the multiple linear regression, here we are having only one input as experience. If we add age to the experience, age plus experience or plus degree of a person. Okay, suppose one person is having BTech degree and 6 years of experience and he's having 35 years of age, what will be its salary? So here age, degree and experience are the 3 input features, and salary is the 1 output feature. So here, if you are having more than 1 input feature, like for example, in surface roughness, we are having cutting speed, feed, depth of cut. There are 3 input features. So when we are having more than 1 input feature, we can say multiple linear regression. So simple linear regression, we are having only 1 input feature. Multiple linear regression, we are having more than 1 input feature. You can see the equation y is equal to ax plus b for linear regression, and y is equal to ax1 plus bx2 plus c for multiple linear regression. And logistic regression is nothing but the classification. It is used for classification problem. It is utilizing some function which is called sigmoid function, and the formula for sigmoid function is 1 is equal to 1 upon 1 plus e to the power x. Okay, so it generates this as shaped curve, which is called sigmoid function. So it is having, we define some threshold value, like in this particular example 0.5 is the threshold value. If it is less than 0.5, it falls to the negative region, and if it is more than 0.5, it falls to the positive region. You can see in this particular diagram, if the value of sigmoid function is less than 0.5, it is falling inside the negative side, and if the value more than 0.5, it is falling inside the positive side. So easily it is used for classification. So again, this is one example of classification using regression. So basically, how we develop this particular equation, which is ax plus b, y is equal to ax1 plus bx2 plus c. I will give you one example. So there are 4 stages in developing the model. One is the modeling, developing a regression model. Then another one is the estimation, coefficient estimation. Then third one is the optimization, and fourth one is the prediction. So here, model, based on which model we have to use: multiple linear model, simple linear model, polynomial model. That we have to decide first when we start developing the model. Okay. So here in this situation, I want to predict the sale based on the price of the product, expenditure on the advertisement, expenditure on the promotion scheme. What will be the sale? So price, advertisement expenditure, and promotional expenditure. We want to build a relationship between these 3 input and 1 output. So here price, advertisement, and promotion are input feature, and sale is the output feature. And beta 0, beta 1, beta 2, and beta 3 are the coefficients which we want to estimate to build the relationship. Our main target here in this equation is to find out the beta 0, beta 1, beta 2, and beta 3. Okay. So estimation of these. So normally there are so many software which will automatically give you the value of beta. Any statistical software, even Microsoft Excel, if you use, will give you the value of beta 0, beta 1, beta 2, and beta 3. So, but how we are getting this? Actually, we are getting these coefficient by using the least square method. Mathematically, if we talk about the least square method, in the least square method, what we do? We calculate estimate the cost function. Cost function is nothing but the mean square error, which I have shown you before. That mean square error we have to minimize. So least square method is differentiate the function with respect to error and equate it to 0. So whatever value you are getting, you will find out this value of beta 0, beta 1, beta 2. So it is nothing but the mathematics differentiation as well as matrix multiplication and inverse. So you will get this value of beta 0, beta 1, beta 2, and beta 3. But you no need to do these calculations because there are so many softwares available in the market which will give you the value of beta. But you have to have data with you. Data you have to collect. Data you have to provide to that particular statistical software. Okay, next. Inference. Third stage is inference. Means you can see this coefficient are nothing but it is showing you the significant of input into the output. For example, suppose x1 is one input and beta 1 is the value, suppose it is negative. If the value of beta 1 is negative, it means if the value of x1 is increasing, the y will decrease. If the value of beta 1 is positive, it means that value of x1 increase, the y will also increase. So it also gives you the negative and positive effect of the input into the output. Okay. But another important term is the beta 0. Beta 0 is nothing but we can say in a statistical form, in the regression form, it is called as intercept. Intercept means if all the input values are 0, still there will be the value of some output. So this statement is very hypothetical in case of this example, which is for predicting the sales. Means if you are having zero cost, if you are having zero promotion expenditure, zero advertising, even you will be having some sales. That is very hypothetical. But in this in mechanical engineering or any other core engineering examples, in any other core engineering example, the value importance of beta 0 becomes crucial. Okay, so prediction. The fourth stage is the prediction. After you develop the model, you have what you have to do. You have to predict the sales. So there are three scenarios are given. Out of these three scenarios, which will give you the best sales, that you have to find out. Okay, am I audible to everyone? Hello.
Yes, sir, you are audible.
Okay. Slides are also visible.
Yes, sir.
Okay. Thank you. So these are the three scenarios, and whatever input you are having, price, advertisement expenditure, promotion expenditure, you are supplying this value into the model, and it will give you the predicted sales. So you can see in the third scenario, you are giving the higher sales. Okay. So if you compare all the three scenarios, in the price, it is in the mid range. Also, the advertisement expenditure on the mid range and promotion expenditure is also on the higher side. Okay. So you can say, okay, this much amount, this much cost I should have for my product, and this much amount I should spend on the advertisement and promotion schemes. So I will get some very good sale. So this is how we develop the regression model. And after developing the regression model, this is how we get the output. This is another type of regression, polynomial. Polynomial means you can see on the red box, blue box, I have increased the power of the model. The fitting will be good, but there is also restriction. As I told you in the previous slide, overfitting you should avoid. You should not try to fit each and every point. That situation will become the model very complicated. And if you are having so many input features into your model, it will give you a good result in the training, but will not give you the proper result in the testing. Or when you properly utilize that model in the real world, it will not give you proper result. So this is polynomial. Sometimes polynomial model work well, but you have to take care of the order of the polynomial. It should not be very high. You can see one example. This data is best fitted by the polynomial model. Instead of straight line, it is best fit by the polynomial model. If we compare the linear model with the polynomial model on the same data, polynomial will give you good result, but there should be restriction of increasing the order of the model. I think this already I have told you how to calculate A0, A1. This slide is very important. How to calculate the mean square error and what is the slope, what is the residual. This slide is giving you some hint. So this graph is between the dependent variable y and the independent variable x, and this graph is valid for linear regression only. Linear regression means only one input and one output. So one input hai x, one input. So these red or orange dot are actual data, and this blue dashed line is whatever the model you have developed. So we have to calculate the difference between your real data and this blue dot. Okay. So every time we have to calculate this orange dot is actual value, and immediately we project this particular dot into the straight line, it will give you predicted value. Okay. So we have to calculate this difference. So blue dash line is representing regression line, orange dot is representing actual data, and black dash line is representing residual or error or difference between actual y minus predicted y, and d is the slope, del y by del x, delta y by del, difference in y direction, difference in x direction. It is y is equal to mx plus c. So m is nothing but the slope and c is nothing but the error. Okay. So here you can see this model does not intersect at 0, origin of the graph. It is having some value in the y-axis more than 0. So this is called intercept. So mean square error formula is summation of y minus y predicted to the power 2 and divided by number of data points. So you can have 10, 20, 100, 1,000, 1,000, 10,000, 1 million data. So you have to take divide by that value. And for each data, you have to calculate y minus y predicted. And I told you why we are using square, because sometimes the difference may be negative and sometimes the difference may be positive. So that is called mean square error. Again, you can calculate root mean square error. You can take the under root of this particular equation. You will get root mean square error. You can also calculate the R square value. So R square value is nothing but the coefficient of determination, coefficient of multiple determination, and its value is ranges from 0 to 100. The value of R square represents how well your model explains the data. More the value of R square is close to 90 or more than 90, your model is good. Okay. Now, mathematically, how you calculate it is the ratio of sum of square of regression to the total sum of square. Okay. So, sum of square of regression, you can see here, whatever the data you are having, blue dots are the real data and blue dashed line are the model which you have developed. So first you have to take the average of each data, blue data. Okay. So you will take the average. So this dash mean, this red dash line on this particular graph is called mean of actual variable. So you have to calculate the difference of of your and actual value to the mean value, it will give you sum of square of total. Okay. So sum of square of total is equal to sum of square of error plus sum of square of regression. If you see this graph closely, so sum of square of error plus sum of square of regression will be equal to sum of total square. So here I am calculating mathematically this value of R square. If the R square value is very good, then you can say whatever model you have developed is good. So in the first slide also, in the first and second slide also, I told you that evaluation of the model is very important. Without evaluation, you cannot directly deploy the model for the real prediction or real working. So if it is satisfying the evaluation parameter, then only you will say that okay, whatever model I have developed is good. So this is the evaluation part. What are the evaluation parameter? Mean square error, root mean square error, R square. This is in case of regression. If we talk about classification, confusion matrix, precision, accuracy, recall, F value, are all these are the evaluation parameter in case of classification. Okay. And I have referred these books. You can also refer these books for the machine learning. These are the very good books. Also, you can see Analytical Vidya in the Google and Geek for Greeks. They are also explaining each and every model pretty well with the proper example. So you can refer internet source also like Analytical Vidya and Geek for Geeks. And you can also refer these books for the understanding of machine learning and different models. In this particular session today, I'm not talking about the deep learning. Deep learning is the different field. Deep learning is the new field, means advanced field compared to machine learning, which require large amount. Whenever you are having large amount of data and unstructured data, like data is in the form of image, data is in the form of video, data is in the form of audio, then you can perform some modeling using deep learning. There are so many deep learning model also like ANN, CNN, RNN, LSTM. Okay, these are used for this unstructured data. GRU. So there are so many models. Okay, so thank you for your patience listening. If you are having any questions, I will be happy to answer. Hello, sir.
Yes, sir.
Yes, any participant, if they are having any questions?
Okay, no, sir. Okay, thank you very much, Dr. Neelesh Kumar Sahu, sir, for delivering such
So thank you
insightful
everyone for your patience listening.
and enriching session on conceptual understanding of machine learning. Your session has beautifully explained the core ideas of machine learning, its algorithms, and its vital role in Industry 4.0. The practical insights and research examples truly made the topic easier to grasp and more relatable for all participants. Before we conclude, I would like to open the floor for 3 minutes of questions or clarification. Dear participants, if you have any queries or doubts, you may please unmute yourself and ask directly or type your question in chat box.
Uh,
I think
you can all, yeah, yeah. You can see my this email ID and my mobile number. Any participant, if they want to communicate with me in future, they can note it down. This email ID and my mobile number. Then they can contact me. Okay. So I would be happy to collaborate with you.
okay. Thank you, sir. Thank you everyone for thoughtful questions.
Okay, sir.
Okay. Once again, our heartfelt thanks to Dr. Neelesh Sahu for sharing his knowledge and expertise with us today. Before we close, a gentle reminder to our participants: please fill out the session feedback form and attempt the quiz, which will be shared shortly. WhatsApp group. Your participation is important for your attendance and education. Thank you all for joining with great enthusiasm. We look forward to meeting you again in the upcoming session of this Atal FDP on Industry 4.0. Okay, thank you
Okay.
everyone.
Thank you, sir. Thank you, sir.
Welcome, sir.